Welcome to qnawire.
So for this LRC series circuit, we have known the power, and we know the voltage, and we also know the frequency. So the power factor is 0.56. So part A is we want to figure out the net resistance R of the circuit. So to do that, we need to apply the power relation for the AC circuit. So power equal to V RMS. So this RMS means root mean squared value times I R RMS and times cosine phi. So this cosine phi is the power factor, which is 0.56 given the problem. So in this relation, the power is 220 and VRMS is 120 and cosine phi is 0.56. So we can solve for this I, the current, directly. It is 3.27 amperes. And then we can figure out the impedance of the problem. So just the VRMS over I RMS. Okay. So the result is 36.65 ohms. And R, the resistance, equal to Z, the impedance, times cosine phi. All right. So this is a very useful relation that you should keep in mind. So Z is 36.65 and cosine phi is 0.56. So R is calculated to be 20.5 ohms. So this is the resistance for the circuit. And part B, we want to find out the capacitance of the capacitor that resulting in the power factor of unity when it is added to the original circuit. So it means that we add another capacitor into the circuit so that the power factor becomes unity. So if we add additional capacity into the circuit, the whole impedance will be so I just say this is Z prime, which is the new impedance, will be equal to R squared plus omega L minus 1 over omega C and minus 1 over omega C primed and squared. Okay? So this L and C are the regional inductance and the regional capacitance, right? And the C prime is the new capacitance. So in this case, we know that the new impedance is simply equal to R because the power factor is unity, okay? So we get another relation. Omega L minus 1 over omega C minus 1 over omega C primed equal to 0. Okay? So we can actually solve for this C prime by using this relation because we can figure out this omega L minus 1 over omega C by using these two results. So let's say omega L minus 1 over omega C here simply equal to square root Z squared minus R squared. Okay. The reason why this is positive is that the voltage leads the current. So just plug in these two numbers, we can obtain that this equal to 30.38 ohms. All right. Then we can just plug this result into this expression, and we can figure out this. We can actually solve for this C prime directly. And don't forget that this angular frequency omega equal to 2 pi times f. And f is the frequency here, which is 50 hertz. So C primed, I found is 105 microfarads. Okay. And part C is so what is the power for this new circuit? So we already know the new impedance, which is simply equal to R. So the power P primed simply equal to V R and RMS squared, which is source voltage over R. R is here. So the result is 702 watts. Okay.